Good day, grade 10 learners. Welcome to our mathematics lesson. I am Sikulile Ngube, and this lesson is proudly brought to you by the Gauteng Department of Education. Are you ready for the lesson, grade 10s? Are you happy in the morning like this? You should be happy. When you're doing mathematics, you should be happy, okay? Right. We're going to learn about the hyperbolic function today. It's going to be a nice lesson because it's what we've been doing all along. Remember what we did? We did what the linear function, and then we did the parabolic function, which is the quadratic function. Do you remember that? And then today we're doing the hyperbolic function. What is the difference between a parabola and a hyperbola? Do you know the difference? Okay, I hope so. Remember, the parabola is one which is U-shaped, cup-shaped, concave up, concave down. Do you remember that? Okay, I'm going to remind you about the hyperbola today. Right, let's make sure that our stationery is ready, our books. We're going to be drawing graphs, so make sure that you have your pencil with you, your ruler, your calculator, and everything that you're going to need for the lesson. And when we start, we're going to be moving. We're going to be moving. And then I'll give you enough time. Remember to send us your input 079 454 9535. 079 454 9535. The main purpose is that everything we're going to discuss today, you have to understand it. So if I'm moving fast, please tell me, say you're moving fast. Slow down. I'll do that so that you can understand, isn't it? Right. And then let's start our lesson. At the end of the lesson, you should be able to plot the basic graph of f of x is equals to a over x. Do you see that? A over x plus q. We have dealt with these ones. Do you remember? We started with f of x is equals to ax plus q, which was the linear function. And then we came to f of x is equals to ax squared plus q, which was the parabolic function. And then today we're doing this one, which is a over x, where x is the denominator, okay, plus q. And we're going to investigate the effect of a and q, just like we did with the previous one, okay? Right. Now, we did algebraic equations, algebraic functions, and substitution. We're going to use these ones a lot in today's lesson. Right. Now, before we move any further, grade 10s, I want us to do a baseline activity. And I want you to sketch the graph. Don't use the table, just sketch using your a there, which is 2. F of x equals to 2 over x. With that a value, you must be able to sketch a graph correctly. Okay, sketching. Where your arms, where should they be? Should they be in quadrant 1 and quadrant 3? Or should they be in quadrant 2 and quadrant 4? And draw your asymptotes. Don't use the table. There's no need for that. Don't just ignore the squares. Just draw the Cartesian plane and then you sketch your graphs, okay? And then after that, we're going to talk about the domain and range and also the equations of the asymptotes and the equations of the axis of symmetry, okay? But for now, sketch the graph for 2 minutes. Let's do it. Right, welcome back, grade 10s, welcome back. Did you manage to draw a correct graph? Okay, I'm going to show you now. I'm going to show you. Please make sure that you do your work. Don't just sit and watch others doing their work. You cannot learn mathematics like that. Make sure that you try. Even if it's wrong, it's fine. It's okay. And then I'm going to give you the solutions. Then you make your corrections, okay? Okay, we learn from our mistakes. Remember that. Don't be afraid of making mistakes. Don't be afraid of making mistakes. And then 079 454 9535. That's our WhatsApp line. Please send us your input, send us your questions. Okay. I want us to discuss as we move on. Okay. Right. We may have to discuss. If you have a question, don't wait. I want you to get your answer straight away. Right now. And then let's sketch our graph. What did we learn in the previous lessons? We learned that if A is greater than 0, when A is positive, the graph is going to occupy the first quadrant and the second and the third quadrant. Okay? We also learned that if A is less than 0, meaning that if A is negative, our graph is going to occupy the second quadrant and the fourth quadrant. Do you remember that? Okay, so now our A is positive, meaning that it's greater than 0. So it means our graph is going to be in the first quadrant and third quadrant. What about our asymptotes? What are the asymptotes? Our asymptotes are x is equal to, let's start with the horizontal one. Remember, is y is equals to 0. And then along the x-axis, y is equals to 0. And along the y-axis, x is equals to 0. Those are the asymptotes. So I'll advise you, when you're asked to sketch the graph, just start with the asymptotes. Those are easy marks to get. Okay? And then we sketch our arms, which is going to be in the third quadrant and first quadrant. We have sketched our graph. Do you see that? Okay. Right. I want us to discuss the domain of f and the range for f. I'm going to give you 2 minutes, okay, for you to try. And then the next 2 questions, I'm going to give you the answers so that we can move on to the main part of our lesson, okay? But this one, for 2 minutes, let's write the domain for f and also the range for f for 2 minutes. Welcome back, grade 10s. Right, what is a domain? Do you remember this? I remember we talked about this last term when we introduced the function concept. The domain is what? It is the input values, which are the x values. Do you remember that? The domain, we're talking about the x values. These are the values we put into the function. Let's look at our function. This is our function, which is 2 over x. Let me just highlight this part only, not the whole thing. 2 over x. Can x be 0? If you look at 2 over x, can x be 0? Can it be 0? Is it fine? If our value, you say, now where there's x, let's put 0. You can use your calculator and say 2 divided by 0 and see what you're getting. Can x be equal to 0? No, it can't be. Why? Division by 0 is undefined. So x cannot be 0. But x can be any other value. Okay? We can say from minus infinity to infinity, but it cannot be 0. Okay? So how do we write that? We say x. So domain is the x values. So we're saying x is an element of real numbers, but, very important, but x cannot be equals to 0. Do you see that? You can write it like that, or there are different formats, but I'm going to use 2 formats for now. Right, okay, I can say x is less than 0 or x is greater than 0. X cannot be 0. It can be less than 0 or it can be greater than 0, but it can't be 0. Do you see that? Because when x is 0, the function becomes undefined. Okay? Right. And then we said we put our input values, then we get our output values. What do we call our output values? That's the range, which is the y values. Do you remember that? The dependent variables, the y value, the range is the same thing. So we're looking at the y values here. Again, we can substitute any x value, but we'll never get a y value which is equal to 0. So that's why even here, y is equal to 0 is the asymptote. It is the asymptote. Remember, the graph is approaching the asymptote, but will never touch it, will never cut the asymptote. Do you see that? So there. So it means y is element of real numbers, but y cannot be equals to 0. Do you remember that? Or you can say y is less than 0 or y is greater than 0. Okay? Right. You can also be taught the interval notation in the classroom. It's still okay. It's fine. Okay. So you should be able to know these representations. Okay. All these representations. Right. Let's move on to the next part. Like I said, I'm going to give you the answers for the next part, which is what? Which is write the equations of the asymptotes. We get such questions in the examinations. Grade 12 examination, they say write the equation of the asymptotes. What type of answers have I seen? I've seen some people writing 0. Just 0. That's not an equation, isn't it? An equation must have an equal sign, isn't it? Okay, right, left-hand side equals right-hand side. So if they say write the equation, write the equation. Okay, so what's the equation of the horizontal asymptote? We talked about this. You said y is equal to 0, so you write y is equal to 0. And then the vertical asymptote, x is equal to 0, you write it there, x is equal to 0. You see that? Okay? Right. You can write that down as your short notes. Right. Some of the things that we are discussing now, we're going to use them in this lesson. So make sure that you understand them. You understand this. Okay? Write the equations of the axis of symmetry. What do you know about the axis of symmetry for a hyperbolic function? How many do we have? There are 2 of them. Okay? There's one which casts the arms of the function. Okay? Let's call it the first one. Number 1. And then there's another one which is in between the arms of the function. Let's call it 2. Okay? If you check 1, is it an increasing function or a decreasing function? Is it going up or going down as you go to the right? It goes up. It's an increasing function. So it means that the gradient is positive. And then if you check 2, as you go to the right, the graph is going down. So it is a decreasing function. So the gradient is negative. I want you to remember this. For the increasing function, the gradient is positive. For the decreasing function, the gradient is negative. What else do you need to know? We've done the equation of a linear function. Okay, in grade 8 and 9, we talked about y is equals to mx plus c. And then even now, when we talk about the linear function, we talk about f of x is equals to ax plus q. Do you see that? And then do you remember what c is? C is the y-coordinate of the y-intercept. Sometimes to make it simpler, we just say it's the y-intercept. But actually, it's the y-coordinate of the y-intercept. So C is the y-intercept. And then M is the gradient. Remember that. So now, where do these two axes of symmetry meet? Here, at this point, which is 0, 0 here. So what is C there? The graph casts the y-axis at 0. So what is going to be our C? Our C is going to be 0. Right. Then these two lines, the increasing function, the gradient is positive 1. It does not change, learners. It does not change. This one, 1, this one, the gradient is 1. And then the decreasing one, this one, which is number 2, the gradient is negative 1. Do we agree? So let me write that. Y is equals to x, let me say plus c for now. And then y is equals to negative x plus c for now. You see that? So we said m is the gradient. So that's why here is 1x. Remember, 1 is invisible. And then here's negative 1x. Remember, negative 1 is invisible. Just put the negative sign. And then what do we put for c? We said is here 0. So it means the equation of this line is y is equals to negative x. And then this one is y is equals to x. Okay? Right. We're going to use this concept as we proceed with the lesson. Okay? So our equation is y is equals to x. And then y is equals to negative x. Right? Remember this. These gradients do not change. I've seen some books, they use a different formula, but I find this one a bit easier. Just remember that your gradient, the other one, the increasing one, the gradient is 1. The decreasing one, the gradient is negative 1. Then your C is where your lines, okay, pass the point where your asymptotes meet. Like here, the asymptotes meet is 0, 0. So our y is 0. So where there's C, you just write 0. Then 0, we don't write it. It's invisible. We remain with this and that. Okay? I try to take time on this so that as we move forward, it's going to be easy for us. But let's say you miss something, don't stress, because I'm going to revisit this part. Okay? Right, should we move on now? We're going to be sketching our graphs and discussing our key features of the graphs. Let's move on. On the same set of axes, plot the graphs of f of x is equals to 1 over x, and then f of x is equal to 1 over x plus q, and then h of x is equals to 1 over x minus 2. What is changing here? It is the value of q. We want to see something. Remember, we said we want to see the effect of q. We have talked about the effect of a. So the effect of q, so it's going to be a over x plus q. We're going to see how this q affects our key features. Okay, I'll give you time to sketch the graphs, and then after that we discuss our key features. Right, now, on the same set of axes, plot these graphs. I have the table for you. You draw the Cartesian plane. Let me give you 2 minutes to draw the Cartesian plane. And then after that, I'll tell you what to do. Just 2 minutes, draw the Cartesian plane. And then after that, I'll tell you what to do. Let's do it. Right, welcome back, learners. I really hope you managed to draw the Cartesian plane that you're going to use for our three graphs. Remember our WhatsApp line, learners, 079 9535. Please send us your questions and send us your input if you have any. Right, now I want us to sketch the graph of f of x. Okay, how do we do that? We're going to use our input and output values, our x and y values. Like for f of x, we're going to use the x values and the red values for y. Like the first one, let me just give you the first two, maybe. -2 goes with -half. Okay, and then -1 goes with -1. Okay, and then where it is undefined, it means that's where your asymptote should be. And then also you see the shape of the graph and try to estimate where your horizontal asymptote is going to be. When I'm going to sketch the graph, I'm going to show you where the horizontal asymptote is going to be, but I want you to try it before I show you, okay? Right, you see by the arms of the graph, but f of x we have done so far, so it's fine. That part of the asymptotes, we're going to look at it when we look at g of x and h of x. So f of x should be easy for us. For both asymptotes, it's fine, it's covered. We did this, so I want correct asymptotes for f of x, both the horizontal and the vertical asymptote. Let's try to plot our graph and then we continue from there. Let me give you 1 minute, because why? We have done the graph of f of x equals 1 over x in our baseline activity. So we have an idea. 1 minute will be enough. Let's do it. Right, did you finish, learners? Okay, if you didn't finish, it's fine. I'm going to give you another minute to make corrections, okay? Let me show you, then I'll give you a minute to make corrections. Right, now we sketch our graph. This is our f of x. This is the horizontal asymptote. This is the vertical asymptote, okay? And then we draw our arms. This is our arm there. And then this is another arm. And then we name our graph. This is f of x, okay? Right, I want us to have 1 minute and make corrections, so that I want this graph to be correct, so that when you draw g of x and h of x, you can easily see what is happening, okay? Right, 1 minute, let's make corrections. Right, welcome back. Did you manage to make corrections? Let's move on to our next graph, which is g of x, learners. Right, so what are we going to do here? We're going to plot our points. Now we're using the x and the blue values for our y values. Like the first point can be, it is -2 and 1 over 2. You see that? And then the second point is going to be negative 1, 0. Third point, negative half and negative 1, like that. And then I want us to try and estimate and find where our horizontal asymptote is going to be. Let me give you a clue. The vertical asymptote does not change, okay? It's still on the y-axis. What is going to change is the vertical asymptote. Where is it going to be? Maybe using your arms of the hyperbole, you can see with the arms is approaching this line, okay? Try to draw that imaginary line using dotted lines, and then after 2 minutes, I'm going to show you the whole graph. Let's try to draw our graph for g of x for 2 minutes. Welcome back, learners. How is it so far? Do you understand? Please send us your input. Okay, send us your input so that we may know how you are doing. And also, if there are any questions, we saw one question about sketching the graph. Please keep on trying. I'm going to assist you to sketch the graphs. Okay, right. I'll also give you time to do your corrections. So let's try. Okay, by the time you draw your third graph, you should be familiar with this. Right. I hope we're not making a mistake of drawing our graphs in different Cartesian planes. We are drawing on the same set of axes because we want to see what is happening to our parent graph. Let's make our red graph, let's call it our parent graph. Now, this parent graph is going to be transformed, there'll be transformation, in the translations, right? So to form g of x and h of x, we want to see that. Right, now, did you manage to sketch? Where was your asymptote? The horizontal asymptote. Where was it? Okay. Where is it? Where do you think it is? It should be at y is equals to 1. Did you get it right? Y is equals to 1. So that's where our horizontal asymptote is. Right? And then when you sketch our graphs, they were supposed to look like this. Something interesting about this graph because it casts the x-axis. We're going to talk about that. Okay, so this is your g of x, right? This is your g of x. Okay, now you should have an idea. Where are we going to have our horizontal asymptote for h of x? Okay, I'm going to give you 2 minutes to sketch h of x, and those who want to make corrections for g of x, let's just do that in those 2 minutes. Remember our WhatsApp line 079-454-9535. Let's sketch our h of x, and then from there we're going to discuss the key features of our graphs. Let's do it. Welcome back, learners. Did you manage to sketch h of x? I hope so. Thanks very much for your question from Dr. Sam Sonyane Secondary School. I really hope that you managed to sketch the graph. Please, if you still don't understand or you still can't sketch the graph, let us know, okay? So that we can try and assist you, okay? Right. Now, h of x, where is the horizontal asymptote? Should be at -2. Y is equal to -2 there, okay? And then when we sketch, remember you're putting the dots plot by point, isn't it? And then our graph was supposed to look like this. Where is the graph? It's like that, okay? Right, this is our graph of h of x. Let me give you 1 minute to make your graph look like this before we go to our discussions. Just 1 minute. Make sure that you have your 3 graphs on the same set of x's. F of x, which is our parent graph, then g of x and h of x. And then after that, we will continue. 1 minute. Welcome back, learners. I really hope you have your 3 graphs now. Let's go to our discussions. Right now, I want us to look at this. Let's look at these 3 graphs, and then we discuss about the equation of the horizontal asymptote and the equation of the vertical asymptote for these 3 graphs. And if there's anything that you can observe them, you talk about it. Let's do it this thing like this. Right, I'm going to give you 2 minutes. I'm going to give you 2 minutes there in the classroom, and then you're going to discuss. Please, let's have order there. You what? You raise your hand and you contribute. Okay? What do you see if you look at these 3 graphs concerning the equation of the horizontal asymptote and the equation of the vertical asymptote? Remember, learners, we cannot afford to even lose 1 second due to disturbances. Let's not disturb each other. Let's have order there and try to answer the questions. Let's discuss on the equations of the asymptotes for 2 minutes, and then I'll come after 2 minutes. I give you the solutions. Let's do it. Right, welcome back, learners. Did you manage to get the equations? Remember this one, let me just add here. It's like plus 0. Do you remember that? Okay, now let's look at the equations of the vertical asymptote. Let's start with the vertical asymptote. Right, I'll start with vertical asymptote. So for f of x is equal to 0. For g of x is equal to 0. For h of x is equal to 0. Okay, because this is the, for all the three, x equals to 0. That's the vertical asymptote. Is it changing? It is not changing. But let's look at the horizontal asymptote now. You can see those dotted lines. There's a green one, red one, and blue one, isn't it? So they are different. Let's start with f of x. This is y is equals to 0. Y is equals to 0. Can we link it to the q value here? Yes, we can. You see, the q value there is 0. Okay, let's go to g of x. This is, you see, this is 1. So it's y is equals to 1. So it's y is equals to 1. Can you link it to the q value here? Remember the q value said we're looking at f of x is equal to a over x plus q. So yes, we can. There's a plus 1 there. Do you see that? That's the equation of the horizontal asymptote. And then h of x, this is negative 2. So this is y is equals to negative 2. So it's y is equal to negative 2. Can you link it to the q value? Yes, we can. You see, this is negative 2 there. So what can we say? We can generalize and say, for this function, f of x is equals to a over x plus q. The equation of the horizontal asymptote is going to be y is equals to q. Okay, y is equals to q. And then the vertical asymptote does not change. It's always x is equals to 0. So we can generalize and say now, for the equation of the horizontal asymptote, y is equals to q. No one will lose a mark on that. You are given an equation, f of x is equal to 3 over x plus 3. What is the equation of the horizontal asymptote? Y is equals to 3. F of x is equals to 3 over x minus 5. What is the equation of the horizontal asymptote? Y is equal to minus 5. You see that? Okay, don't lose marks on that. Now you have learned something, isn't it? Now, because of time, I'm going to give you 1 minute for discussions so that we can cover more things. 1 minute for discussions. Let's discuss the next thing. I want us to talk about the domain and range for these three graphs for 1 minute. After 1 minute, I'll come back. Let's do it. Right, welcome back, learners. Did you manage to discuss? 1 minute was too short, isn't it? Maybe you couldn't even finish your sentence. But let's start. Let me show you. That the domain, we talked about this. We say that for f of x, x element of real numbers, but x cannot be equal to 0. Okay, or you can say x less than 0 or x greater than 0. Let's talk about the domain for these two. What about g of x? The domain is still the same asymptote, x equal to 0. So x cannot be equal to 0. So it means still the same x element of real numbers, but x cannot be equal to 0. But x or x, you can write it like this, x less than 0 or x greater than 0. Do you see that? So the domain does not change. Do you see that the q value does not change anything to do with x? It changes things with y. Let's check the range. The range now is y element of real numbers, where y cannot be equal to 0 for f of x, or you can say y less than 0 or y greater than 0. But now g of x, Now, asymptote is y is equals to 1. So the range is now y element of real numbers, but y cannot be equals to 1. Do you see that? Or you can say y is less than 1 or y is greater than 1. Can you link this to the q value? Yes. You see that? So we can generalize here and say our range is going to be y element of real numbers, but y cannot be equals to q. You see that? Or you can say y is less than q or y is greater than q. That's the range. And then the domain does not change. Okay? Right. Let me explain f of x and h of x. Right. So same thing here. Same thing here. We said the range is still the same, x element of real numbers, but x cannot be equals to 0. X element of real numbers, but x cannot be equals to 0. I'm writing one format now. X element of real numbers, x cannot be equals to 0. Do you see that? And then the range, we say this one. We talked about g and f of x. Let me just write fast. Y element of real numbers, but y cannot be equals to 0 or y less than 0 or y greater than 0. Okay, that is f of x. And then g of x was y element of real numbers, but y not equals to 1, or you can say y less than 1 or y greater than 1. But what about h of x? The asymptote is here. Y is equal to -2. What is it going to be? The range is y element of real numbers, but y cannot be equals to -2. Or you can say y less than -2 or y greater than -2. Linked to the q value here, we can generalize and say our range is y element of real numbers, but y not equals to q, or y less than q or y greater than q, like that. That's the range, domain and range. Okay? Right. Time is flying, but let me give you just 30 seconds. I won't go anywhere. 30 seconds, and then we move on after that. Just 30 seconds for you to write your short notes. Okay? Let's do it. Right. Welcome back, Cretans. I really hope you managed to write your short notes there. Let's move on to the next feature, which are the y-intercept and the x-intercept. Okay, does the red graph cut the x-axis and the y-axis? No. Okay, so here we say there are no x-intercepts, no y-intercept. Let me just say none, then none. Right. Okay, you can write that. Let's look at g of x, the blue graph. Does it cut the y-axis? Because the y-intercept is where the graph cut the y-axis. Does it cut the y-axis? No, it doesn't cut the y-axis. Because actually the y-axis is the asymptote. Remember, the graph does not cut the asymptote. So none. What about the x-axis? Yes, here. Here. You see that? And we can calculate that. Let me do it. G of x is equal to 1 over x plus 1. And then x-intercept, y is equal to 0. Remember that. So we put 0 here where there's y. Remember, g of x is y is equals to 1 over x plus 1. Then we can bring the 1 this side, or subtract 1 from both sides. Is going to be -1 is equals to 1 over x. And then you can cross multiply or multiply by the LCD. -1x is equals to 1, because 1 over x times x is 1. And then divide by -1 both sides, x is equals to -1. You see that? So these coordinates here will be -1, 0. You see that? So there is an x-intercept, which is -1, 0. Right. And then What about the h of x? Does it cut the y-axis? No, there's no y-intercept. But it cuts the x-axis here. Then if you calculate that, you can do that during your spare time. If you calculate that, you must get half, 1 over 2. Okay, 1 over 2 like that. You see that? Okay, so that is about the x and the y-intercept. Remember what these things are. X-intercept is where the graph intercepts the y-x-axis, and then the y-intercept is where the graph intercepts the y-axis. Right. The equations of the axis of symmetry. Can I explain this because of time? Right, we talked about this when we did our baseline activity. Do you remember that? Right. Okay. So I'll start by explaining the equations of the axis of symmetry for f of x, and then we go to g of x, and then we go to h of x. Want to see how the effect of q affects this. Okay. So now the red one, there's one which cuts the arms, and then there's the one which is in between the arms, and then this passing at y is equals to 0. So what would be the equation here? We said from y is equal to mx plus c is going to be y is equals to x, and then y is equals to negative x. So for f of x, the equations are y. What did I write here? Yes, negative x. So it's going to be y is equal to negative x and y is equal to x. That is for f of x. Okay, let me write it. Plus 0. Remember that. Now, let's talk about g of x. Right? Let me just find the color. Right, this line is going to pass here, and then the other one like this. What has changed here? The gradients have not changed. It's still one with gradient of positive 1 and the other one with gradient of negative 1. So it's going to be y is equal to x. And then what is the y-intercept now? It is at 1. So it's going to be y is equal to x plus 1. And then this side is going to be y is equals to negative x plus 1. Okay? And then we write our equations like this. Now, is it linked to the q value? You see that? Now, even without looking, you can write the equations of the axis of symmetry for h of x. Do you see that? Because it's linked to the q value. Okay, can you say it? What are the equations? It's going to be, let's start with the one with the positive gradient of positive 1. It's going to be y is equal to x minus 2. And then the other one is going to be y is equal to negative x minus 2. Okay? Right. So that is for h of x. Right, because it's going to cut here. I can't find my pen now. Okay, let me see. Right, it's going to cut here. And then the other one is going to cut there. See, at minus 2 here, negative 2. So it's going to be y is equal to x minus 2, and then y is equal to negative x minus 2. You see that? Those are the equations of the axis of symmetry. And then it is linked to the q value. So we can generalize and say what? For this graph, f of x is equals to a over x plus q. The equations of the axis of symmetry is going to be y is equals to x plus q, and y is equal to negative x plus q. You just use the q value there. You see that? Okay. Right. 1 minute to just write your short notes, then we continue after that. Right, welcome back. I really hope you've managed to write your short notes. Right, let's move on now. Okay, this one, I wanted us to do an activity, but because of time, we won't manage to do that activity, okay? Right, but let me give you 1 minute to discuss these three graphs. Talk about the domain and range, x and y intercepts, the equations of the axis of symmetry, and then the equations of the asymptotes. And then after that 1 minute, I'm just going to give you the answers. So when I'm giving the answers, you won't even have time to write. I want you to sit and just listen to me. I know listening is not the best way to learn, but because of time, I'll just go quickly through the key features with you after 1 minute. Discuss for 1 minute. Right, welcome back, learners. Welcome back. Right, I really hope you managed to discuss in this short time. But remember, learners, the advantage about these videos, you can even replay them, you can even rewind and go back a bit if you missed something, isn't it? Do you know that? So you can do that later. But now let me give you the answers. Let me give you the answers. Right, f of x, the equation of the horizontal asymptote. Like I said here, there's a plus 0. So I'm going to use mainly the value of q, because we have seen that the value of q will give us our key features here. So f of x, the horizontal asymptote, will be y is equals to 0. I'm getting that from the q value. And then for g of x is going to be y is equal to negative 1. I'm getting that from the q value here. And then for h of x is going to be y is equals to positive 1. I'm getting that from the q value there. Okay. And then the vertical asymptote we said is not affected. So it's going to be x is equal to 0, x is equal to 0, x is equal to 0. Do you see? I didn't even look at the functions. I just looked at the equations. You can get these things from the equation. In the exam, they can give an equation and say, state the equations of the horizontal asymptotes or vertical asymptotes. You see that? You can just get those things from the equation. Okay? And then the next one, the domain does not change. Let me write one format because of time. X element of real numbers, but x cannot be equals to 0. X element of real numbers, but x cannot be equals to 0. Sorry, cannot be equals to. X element of real numbers, x cannot be equals to 0. You see that? Now the range is one which changes. So y element of real numbers, but y cannot be equal to 0, linked to the q value there. Right, y element of real numbers, but y cannot be equals to negative 1. Did I use negative 1 in the previous one? I think I made a mistake somewhere. But please, if I made a mistake, you'll understand, okay? Right, I was moving fast. Now, I think last time I used 1, positive 1. Not sure, but that's fine. Now, getting from q here, and then y element of real numbers, and then y cannot be equals to positive 1 there. Do you see that? Okay, I'm getting those things from the equation there. You see? Okay? Right. And then the y-intercept, all the three graphs, they're not cutting the y-axis. So, none, none, none. The graphs are not cutting. Actually, this is our asymptote. You see that? And then the x-intercepts, the red graph, our parent graph does not cut the x-axis, so it's none. But let's look at g of x. cuts here at -1, so it is there, -1, 0. And then h of x, where here at 1, so this one is 1, 0. Is there, okay? The what you call that, the x-intercepts are there, okay? And then the equations of the axis of symmetry. Can I just write these ones without even looking at the graphs from the equations? Yes, I can, right? Okay, because this one will be y is equals to x and y is equal to -x. Then this one, q is -1 here, is going to be y is equal to x minus 1, or y is equal to -x minus 1. Then h of x, our q is +1 here, so it's going to be y is equal to x plus 1, and then y is equal to minus x plus 1. Do you see that? From the value of q, we can do that. Okay, right. Now let's move on to the last part. This was supposed to be homework, but let's just summarize our lesson, then we'll be done after that. Let's just summarize our lesson. What did we learn? For y is equals to a over x plus q, we say the domain x is element of real numbers, but x is not equals to 0. Oh, I'm confused. I thought I made a mistake. The domain, this is the domain. Oh, yes, this is perfect. Okay, and then the range now is the one where we say y is the element of real numbers, but y is not equals to q. You see that? Okay, we learned that today. And then the equation of the horizontal asymptote is y is equals to q. The vertical asymptote does not change. X is equals to 0. Okay? Right. For y is equals to a over x plus q, the equation of the vertical asymptote x equal to 0, I've said that. And then the equations of the axis of symmetry, we said is going to be y is equal to x plus q. This does not change. Or y is equal to -x plus q. This does not change. You see that? So this is how you find the equations of the axis of symmetry. Okay, right. Thank you very much, grade 10s. The last part of our lesson, we're moving a bit fast, but I really hope that you learned something. And because it was just sort of a repetition of what we have been talking about all along, and we are going to meet in our next lesson. Which function are we going to look at in the next function? In the next lesson? Which one is left to look at? The exponential function. We're going to look at the effect of q and a on the exponential function. Let's meet next week for our next lesson.